our Algebra 2 review for test 1 through 35, 2020-2021 school year. This isn't always the quarterfinal. This year it's the quarterfinal. All right, so these are our most missed questions. Evidently nobody missed question number 2, which is fantastic. We're going to delete these. We're going to pull up the actual test itself, try to work out some of these questions. Okay, yeah, question number 2 was on the test. All right, is this the same review that you guys received? Okay, cool. All right, let's take a look at question number 12. All right, this one I did up on the board, I think, but probably for the other class. All right, it says graph the quadratic function, y equals x plus 2 squared plus 2, and we want to compare it to the parent function. Anybody have a clue about function? Y equals x squared. So the parent function is y equals x squared. So all I have to do in my graphing calculator, right, if I want to see what these two things look like, is I can actually graph them both. Give me a second here. I'll pull up a graphing calculator emulator and show you what that looks like here pretty soon. Okay. All right. So the parent function, I can guarantee you, in fact, I'll show you, I mean, once you kind of know what is going on, the parent function is going to look like that. Okay. I know this because it is positive, right? X squared is positive. That tells me that it opens upwards. And the rest of it tells me that the vertex of it is at 0, 0. All right, so it's at 0, 0. It's opening upwards, and because there's no coefficient in front of x squared, that tells me that it opens at a standard rate, which means it's not super wide, it's not super small, it's right in the middle. It's the parent function is like the Goldilocks of its particular type of function. Does that make sense? All right, which means we can change certain aspects to it that are going to make it either wider or narrower, or change the vertex, or flip it so that it's going down instead of up, right? We can do all those types of different things. All right, so let's see what the parent function looks like, see if I was correct. X squared, graph it. Looks pretty similar, right? Okay. All right, now let's see what happens when we do the rest of this. Okay, we'll leave that just like it is. Parentheses, x plus 2 squared plus 2. Now before I do that, before I hit graph, all right, I want to indicate to you that I know what these individual parts do. And if you know what the individual parts do, then you don't need the graphing calculator to tell you what's going to happen. Okay? All right. Is this still here? Let me underline it so that in the video you know what I'm talking about. Is this positive right here? Yes, there's not a negative sitting out in front of it, which means the function is still going to open up. Okay, it's still going to open up. Okay, is there any kind of whole number, coefficient, or fraction out there in front of that parentheses? Okay, which means is it going to be narrow or wide or standard? Standard. We're not changing how it opens. Okay, so it's going to open at the exact same rate that our parent function opens at, okay? Now, this plus 2 here, that plus 2 is counterintuitive, all right? Meaning that with the x being plus 2, that means it's going to go to the left 2, okay? So you remember how when we were working with scientific notation, right? How if I go to the right, we are subtracting, and if we go to the left, we're adding. Okay, well, this is also counterintuitive. Okay, as we add to the x inside the parentheses, I move the vertex to the left. Okay, now, the plus 2 on the outside is intuitive, meaning that it does what it says it's going to do. And so that tells me I'm going to go up 2. That makes sense? Okay, I know, I'm sorry. I'm going to move you guys here a little bit. Okay, hopefully you can still see. Okay, all right. So what I know, based upon looking at this without plugging it in the graphing calculator, is I know that it's going to go to the left 2, it's going to go up to, and it's going to open standard. Okay, so the vertex is now here, and it's going to look like that. Okay, all I'm doing is taking the parent function, shifting it 2 places to the left and 2 positions up. All right, now let's pull back our graphing calculator and see what it says when we graph it. Do we find that our graphing calculator is fair? Sorry, we changed batteries out. Now we have audio again. They probably went out who knows how long ago. All right, let me find my marker. Okay, so we should be able to see even from the video how plus or minus x. Now, if that's x minus 2, what is that going to do? 2 to the 2 to the right, all right? If it's x minus 2 squared minus 2, that minus 2 on the end would take me down, okay? So we understand how that works, okay? All right, so we understand how line of symmetry works. If it opens up or down, my line of symmetry is going to be a vertical line with an equation of x equals at the x coordinate of the vertex, okay? If it opens to the side, which you guys won't see, right? I don't think that you'll see in this class this year, okay? But if it did, we would have a line of symmetry that cuts through the y coordinate of our vertex, so it would be a y equals that number, okay? We've graphed it on a coordinate plane, explained how the graph is shifted. We've stated that it's shifted 2 to the left and 2 up, so we would state that. How does the graph compare to the graph of y equals x plus 5 squared plus 2? Okay, well, the graph x plus 5 squared plus 2 would be shifted 3 more to the left. Does that make sense? I think that's all I would have to say. I don't know what the answer key says. Can we tell me what the answer key says on part E of question 12? It's shifted 3 more to the left.
The graph is shifted 3 units to the left of the graph.
Okay. Explain how you can tell without graphing. We can tell because of x plus 5, okay, and we understand that plus means to the left. Okay, any questions left on 12? Is that easier than what you thought it was? Okay, great. Okay. All right. Let's see. Question 27. How's the home team doing? You guys getting all of this? Home team is people that are playing from home. So that's our Emma, Jeremy, Niasi bros. Okay. Okay. Determine whether the function of the graph is To me, that's the definition of a code yellow, is when you really have to go to the bathroom. I mean, I guess a code brown. It depends upon what kind of bathroom trip you need to make. That was a joke, but nobody got it. All right. All right, moving on. Glad that statement has been preserved. To determine whether the graph is continuous, discontinuous, and or discrete, then find its domain and range. Is this continuous function? No. Okay, no. Why not? How do we know? Right, it's broken up. Okay, so therefore it is discontinuous. Is it discrete? No. How do I know it's not discrete? It would be just individual points, right? And because it's not just individual points, it is not discrete. Okay. Here, ambulances after a code yellow. That doesn't seem good. All right. Let's see. Domain. What values are we talking about when we talk about domain values? X values. So, all right. X, does it go all the way to -1? No. Okay. What would we say then? What is its relationship to -1? Greater than, but not equal to, but not equal to. Okay, how far to the right does it go? 4. All right, but it goes to 4, so it is less than or equal to. So this is my domain. Does that make sense? Okay. Now what values does range refer to? Y values. Okay, so y what? What is the relationship of our y values? What y values? Y values. +1 and +2. Is it greater than those? It's not. Is it less than those? It's just what? It's just equal to those values. It's equal to what values? 1 and 2. Okay, it's just equal to them. Okay? Does that make sense? So, honestly, what we should be able to do, the very first part of these types of questions is, can we find a domain and range based upon a graph? Later on in the year, you'll be given the domain and range and ask, can you graph that? Does that make sense? So that's going to be the next hardest step is, given the domain and range, give me the graph. Okay? Because really, that domain and range tells me everything I need to know. All right. Let's see. We need 28. First, let's do some harassing. Yes. Okay. Determine whether the graph is continuous, discontinuous, and or discrete. Determine whether it's a function or relation. Determine the domain and range of the function. Do we need to determine if the last one was a... I guess we did not. Okay. Is it continuous? Nerp. Okay. It is not continuous. It's broken up. Is it discontinuous?
Yes.
If it's not, it's one or the other, right? If it is not continuous, then therefore it must be discontinuous. Okay, thank you. All right. The next part is, if it's discontinuous, is it also discrete or not? Is this discrete? Yes. Yes, because it is just individual points. All right, so it is also discrete. Determine whether it is a function or a relation. Does it pass the, what test is it? Does it pass the vertical line test? Somebody said no. Somebody said yes. Yes or no?
Yes.
Raise of hands. Yes? Yeses? Several yeses. Any no's? Nays? No longer feel nay. Okay. Let's check. Does that pass the vertical line test? Does that pass the vertical line test? Does that pass the vertical line test? Does that pass? Sweet. It passed the vertical line test every time. Therefore, it is a function. Okay? Function. Now, if they had had something like that, would that now pass the vertical line test? No, therefore it would be a relation. Okay, cool. All right. Yeah, so I mean, I don't know if you ever find that, I guess, in a family tree, things go vertically, right? That's not the kind of relation you want. Joke again. No, sorry. All right. You want things to branch out, right? You want it to pass the vertical line test. Okay. Domain and range. Domain, x values, right? Domain. All right, what are the x values? X values?
-8, -6.
Okay. Range? Oh, sorry. Thought you were on range. Range? 2. That's it, right? It's the y value. Super duper. Okay, that was 28. Moving on with our lives. Yeah, come on. All right, 6. Huh? Psst, don't tell me what to do, okay? It's my life. 6. All right, like a certain level of order in my life. Combination lock, like the one shown, has 3 dials. All right, you've seen things like that. Each dial has a number ranging from 0 to 6. How many different combinations are possible with the lock? I guarantee I know what you did. All right, let me see if I'm right. I'm guessing that, let's see. How many of you picked D as your answer? 1, 2, 3, 4-ish maybe. How many of you picked 216? 216 combinations. Let me guess, your math looks something like this. 6 times 6 times 6. Right, you bunch of antichrists. Okay? Let me tell you why you're wrong. Here, count from 0 to 6. Count on your hand. 0, 1, 2, 3, 4, 5, 6. There's 7 numbers. Right? 7 times 7 times 7 is 343 combinations. Yeah, because I helped you. The devils. Okay, now granted, if the question did say from 0 to 5, you would be correct in saying 666, so that makes me uncomfortable. It was really weird the other day. I wrote our check out to the church. We tithe once a month, and then I think the number on my check, the last 3 numbers on my check number were 666. I was like, saw that too late. So, okay. All right. Do we understand what we did wrong there? Right. We just saw the number 6. Well, yep, must be 6. Right. Anytime they include 0, count. Right. Count. If they say 0 to 9, how many numbers is that? 10. Okay. Stop. Think about it. 10. A student is choosing a 4-digit password. Only the digits 1 through 7 are allowed. How many passwords are possible if the digits are not to be repeated? That is important. Importante. Right? I don't know if that's Spanish or not. All right. How many little places should I have here? 3?
4.
Oh, 4. Okay. Okay. Let's see. How many can I put in the first spot? 7. Okay. But so if you want like a test through on this, like we can put the numbers 1, 2, 3, 4, 5, 6, 7, right? And just as we understand how this works, let's say I pick 3, right? I pick 3 to go in the first spot. Okay. Now it said cannot be repeated, so whenever I go through here, I can do 1, 2, 4, 5, 6, 7. How many are there now? 6. All right. There's 6. All right. 5, 4, right? If I went through here and I said, I'm going to pick 4 for the second spot, I'd go, 1, 2, 5, 6, 7, right? So these numbers up here don't represent the numbers that we're picking for our code. They represent the number of numbers available to us. Does that make sense? So 7 times 6 times 5 times 4 is what?
800.
Yeah, you can't put 800 and something on your test. 800 and what? 840 possible passwords. Okay. Yeah, you want to multiply them. Okay. Multiplication.
I got the first one right, so I don't know why.
We may never know. It's like how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop? We don't know. The world may never know. All right. Back to 25 through 26. If only somebody had told me to go ahead and do 25 and 26 while we were already here, would have saved us a bunch of time. Find the zeros of the quadratic function. Okay. All right. You remember how you saw a question on like the last couple of tests that said like x squared minus 81, right? And everybody, because you've seen it so many times, like, know the answer because I memorized it, x minus 9, x plus 9, right? 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 The rule that I told you was what? If I see just an x squared and minus a perfect square, I should do what? All right, square root it, and then I'm going to have a what for my operations on the inside? Plus minus, because it's a sum difference, right? Okay? So you could do that with 64, right? What's the square root of 64? 8 and 8. All right, but here's the other part, is that 9 is also a perfect square, correct? All right, so if I have a perfect square x squared minus a perfect square, I can actually square root both numbers, right? So what's the square root of 9? 3x, 3x, and then you can FOIL that to check your answer, but it should be 3x plus 8, 3x minus 8. Yeah. Well, we're not, I mean, you can FOIL to check your answer, but you're not foiling it to get your answer. Questions there? Does that make sense? So let's, just so I can tell that you understand what I'm talking about, right, I'm going to give you another option here. I'm going to say, find the zero. Oh, we didn't find the zeros though, right? All right. So we got to finish it. All right, we had what, 3x minus 8, 3x plus 8. What's the next step there? Set them equal to 0. So 3x minus 8 equals 0. 3x plus 8. Okay. All right. Do what here? Nope. Don't divide by 3. We do kind of opposite of order of operations. So I'm going to add 8, and then do what? And then do what? So I got 3x equals 8. Go ahead and what? Divide by 3. So I get x equals positive 8 thirds. Over here, subtract 8, 3x equals negative 8. Divide by 3. X equals, all right, so those are my two zeros, right? Okay, we understand what to do there? All right, again, I still want to make sure that you guys know what to do in that situation, at least to start with. So if I got something like 25x squared minus 49, okay, so tell me what is going in the sets of parentheses. All right, and then I would set those equal to 0, and I would get positive 7/5 and negative 7/5, right? Right, but that's, I mean, I would subtract 7, divide by 5, that's how I'd get the negative 7/5. Add 7, divide by 5, I'm going to get positive 7/5, right? Okay. Okay. What? No, 26 is not exactly the same. In fact, 26 is kind of exactly, it's the same, but we're going backwards, okay? Okay, so basically we're saying this is that x equals negative 2 thirds and x equals 3. Okay, so how then, remember how we got, what was the answer on the last one? Was it 3/8 or 8 thirds? 8 thirds? All right, so imagine that we had 8 thirds. How would I get back to that, 3x minus 8? All right, well here I would have to do what with this 3? I got to multiply by 3. Okay, so that's giving me 3x equals negative 2. How do I move the 2 across? Add 2. So I'm getting 3x plus 2, right, for that factor. Okay, and what about x equals 3 over here? How do I move that 3 back over? Subtract 3. So I'm getting x minus 3 here. Now it says write the quadratic function. Is this the quadratic function? No, it's not. What do I have to do with it? FOIL. So 3x times x is 3x squared. 3x times negative 3. Negative 9x, 2 times x, positive 2x, 2 times negative 3, negative 6, combine like terms, 3x squared. What's those like terms? Negative 7x minus 6, that's the quadratic function. Okay, so start at the end, work your way back to the beginning. Okay? Does that make sense? Understand what's going on there? All right, that was 26. Those are the 1, 2, 3, 4, 5, 6, 7 most missed questions. What other questions on this do you want to look at? 5 and 11. Anything else? No? 5 and 11? All right, so let's look at 5 and 11. 5, what is the range of the discrete function? All right, range is what?
You did this on the board.
Range.
You said it was A.
Okay, well, range is y values, right? So I've got negative 8, 3, or sorry, negative 8, 7, negative 5, negative 5. All right, so start with the lowest value, which is negative 8, negative 5, and 7. Does that make sense? Range in this case is not referring to the biggest number minus the smallest number. Okay? That only works in a set of data, right? Where all I have is like, let's say, what is the range of test scores, right? Because there's no function being used there. So when we talk about the range of a function, right, we're talking about the y values. Okay? 11. Okay, 11. Solve the system of equations by substitution. What I would do with this, substitution means to cancel out a variable. All right, so I have to either pick, am I going to cancel out x's or y's? Cancel out the x's. What did you multiply the top equation by? I would multiply by 7.
No, okay. I think what I did was I just put it into slope intercept form for that first equation. So I added 4x to both sides, and ay equals negative 4x plus 44. Then y.
Okay, so you're not solving by substitution then.
Yeah, I guess not. My plan was to then use what y equals and substitute that.
Okay. So I'm going to show you how to solve through substitution, and then I'll solve using your method to see maybe what went wrong. All right, so here this would be negative 28x plus 56y equals whatever 7 times 44 is, which I don't know off the top of my head. You can do whatever you want to do. It's a free country. I'm glad that's being said on this video with no context whatsoever. All right, what is 7 times 44? 308. Okay, and then I'm getting positive 28x minus what 24y equals whatever 4 times negative 37 is, which is negative a number. Negative 148. All right, now if I add these two, what's going to happen to the x's? Cancel out. Okay. I guess I'm really not solving via substitution. I guess this is what you call solving through elimination, but still. All right, now I have 56 minus 24. What's 56 minus 24? 32y. What's 308 minus 148? 160. Okay. What's 160 divided by 32? 5. Okay, so y equals 5. Once I know that y equals 5, I have negative 4x plus 8 times 5 equals 44. Negative 4x plus 40 equals 44. Negative 4x equals 4. X equals negative 1. Well, because I'm using this, and it remains a negative 4 throughout, it would be a negative 4.
So for substitution, I
Okay, I'll get to that here. Let me erase this. Can I erase? So we know our answer should be -1 and 5, right?
Yeah.
Okay. Okay. Well, then you probably did it right if you got it right. Okay, so if I was going to solve by substitution, yes, you're right. You would have to take one equation and solve it for a variable. So you said you picked the first equation, Cole, and this was your question, so we're going to do that. All right, so what did you solve for, x or y? You solved for y. So you added 4x to the other side, right? So you got 8y equals 4x plus 44. You divided by 8. You got y equals 1/2 x plus what? Plus 11 halves, okay? So I know that y equals this, so now I can do 7x minus 6 times 1/2 x plus 11 halves equals -37, right? 7x minus what? 3x. Cool. All right, that's going to give me what? -66 divided by 2, which is going to give me what? -33 equals -37. Combine like terms, so that's giving me 4x. Add 33 to the other side, which is giving me what? -4. Divide by 4, x still equals -1. Plug it back in, right? Solve for y. Y would be 5. Does that make sense?
I tried to substitute the slope-intercept form into the same equation.
No, it can't do that. You got to substitute into the other equation.
Then I got 44 equals 44.
Right, which it should, because it's going to be equal to itself, right? So you'd end up with infinite solutions there. But no, you have to substitute into the other equation. Does any of that make? Do I need to do the other one for you, Brianna? Okay. Uh huh. All right. Any other questions from this? Go ahead. Okay. Do you have a preference between 20, 21, and 22? Identify the excluded values. I mean, I would pick maybe the most difficult one. 21. All right. So 21, you want the excluded values. All right. So what can I absolutely never have in the denominator? What can the denominator never, ever, ever equal? 0. So that means I would have to find the zeros of that quadratic function. Does that make sense? So as I do that, the first step is to factor that. And it looks like I could divide all of this by 5 to reduce it, right? That's going to give me x squared plus 8x plus 7, right? Right? Then I can find the x's of that. That's going to be xx plus 7, 1. Right? Set those equal to 0. X plus 7 equals 0. X plus 1 equals 0. But keep in mind they can't equal 0, right? They're the excluded values. So x is not allowed to equal -7 or -1. So the excluded values are -7 and -1. Does that make sense? Now, that's not the end of the question. That's the first part. That's the excluded value part. The simplifying the expression, we've done at least about half of it because we know this simplifies in the denominator to x plus 7, x plus 1.
How did you get the 7?
X plus 7 equals 0. Subtract 7. Okay. Same thing over here. X plus 1 equals 0. Subtract 1 equals -1. All right. Now we have to come back to, if we want to simplify the expression, we need to do the numerator. Can I divide everything in there by 2? All right. That's going to give me x squared plus 6x minus 7, right? Factor that. Okay. That's going to be x plus minus, right? Plus 7 minus 1. So as I put that over here, I get x plus 7 over x minus 1. What cancels out? The what? What cancels out? X plus 7 cancels out. Okay? So my final answer for the simplified form is x minus 1 over x plus 1. All right? So that's simplified, and these are the excluded values. Okay, does that make sense? All right. Well, we did this. I'll probably, I don't know. We'll see how far I get with the other class. Okay.